in this video, yeah, we're going to talk about what set notation. It's going to be the second video on theory of sets. So the first video is now what's called set and the various type of sets. If you have not checked out that video, please the link to this video will be at the description below, because that first video is very important. So, but in this video, yeah, our main focus is going to be on what set notation, the different way you want to represent what set, the notation. So the first one here called the first one is called number one, elements of sets. All right. Now, when you say various element or a element is part of the set, we also what's called element of sets, right? So the symbol for element of set is this. This is the symbol. I don't know what it's called, but this is the symbol used to represent element of sets, right? So that is a certain element or a given element is part of a set. Do you understand? So for example, here we have, if you have something like this, A as a set, here we now have what A, B, C, D, right? How do you represent all these members to be an element of what to this A here, right? So you can see that A is an element of what of this small letter A. This one here is an element of this set here, right? So here you can see that A is an element of what capital letter A is okay. B is an element of what A. But we don't use all these things here. Element, no, we don't use. We have a certain way we can represent here, which is on here. So we can say that A is an element of A. Just that B is an element of A. C is an element of what of A. D is an element of what of A, right? Now, any element or any member outside each other is not part of this A here, is not an element. For example, here, let us define that one. B is equals to what? Let us say 1, 2, 3, 4. Right? Now, 1 is an element of B, but 1 is not an element of what of A. Do you understand? So you can see that. Now, I want to talk about not an element. You use this symbol here, not an element. This one means what? Not an element, right? So, any member outside this one that is not part of this set here is called not an element. For example, here you can see that 2 is not an element of what? Of A. This is that 2 is not an element of A, right? But 2 is an element of what? Of B. Do you understand? So the first set notation you need to know is called element of. Do you understand? So this is how you represent it. So this is what the first one here. Now let me talk about the second one, number 2. It's called cardinality. Cardinality of sets. Of sets. Now, what does cardinality of set means? It means that what? The numbers of elements in that set. The numbers of elements in that set. Now, here means what? Numbers of elements in a what? In a set. Please take down. So when we talk about cardinality of set, you're talking about numbers of elements in a given set. That is cardinality. So, for example, here we have, let's pick this guy here. Here we have A. 1, 2, 3. Now let us pick. So here we have what? A, B, C, D, and what? And E. Right? Now, if they should ask here, what is cardinality of this set here? Now, if they should ask you what is cardinality of this set here, what they are simply asking here, how many members of this set have? Just or how many members are in this set? That is just it. So you can see that the cardinality, now you don't spell the word cardinality, right? Use like this. you want to talk about the cardinality of this one here, you can just say n is okay. This is how you represent it here. So n, then open bracket, then the set itself, right? So you can say n, which this will represent what? Cardinality of that set, which called numbers of elements in that set. How many numbers of elements do you have here? 1, 2, 3, 4, 5. Goes to what? 5. So the cardinality of this set is what? Is 5. If, for example, here we have x equals to, here we have 2, 4, 6, 8, 10, 12, 14. Here we have what? 16, 18, 20. Right? So if they ask here, what is cardinality of this set here? They simply ask you how many members of elements do this set S have, right? Or how many numbers of elements can you find in set X, right? So here you go to do what? Cardinality of sets is okay. Cardinality of set is equals to here. You simply count what the members of that set or elements of that set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have what? 10. That is it. So this is called cardinality of set, as easy as that, right? So if you are following this, if you are following this class, I understand what I'm doing here. Please leave a message that you are following what this class. And if you not subscribe or follow me on any platform you're watching this video, please kindly subscribe and follow me on the various platforms, because we produce videos like this on a constant basis. So now we are done with cardinality of set. The next thing we want to look at is what is union of sets, the union, right? Number 3, union of what? Of sets. Now, what is the symbol of this one is what is this? This means what? The union of set. It's not this one, it's not you. Remember, you means what? Universal what? Set. You and this are what? Are the same, right? These two are called universal what? Set. But when we talk about union of sets, right? You're talking about what? This one here, not you. So just note the word difference. So when we talk about union of sets, right? Union of sets is a combination of what? Two or more sets without any repetition, right? Let me go again. Now we talk about union, like the word union, that is you are uniting, or you are bringing two things together, right? So that's you are marrying what? Two sets, that is union, two or more sets, right? So when we talk about the union of a set, that is you are combining two or more elements together, two or more sets together without any repetition of the what? Of the elements. Now let me explain to you here. For example, here we have a 1, 2, 3, 4, 5, 6, 7, right? So for example, here we have this one here. Then B is equals to, here we have 1, 2, 3, A, C, A, C, F, and G. So I'm just taking random stuff here, right? Now, let's say we are saying union of sets, union of these two sets here. Then you are combining these two sets, right? So you say find A union what? B, right? Now we are going to combine these two sets here, right? So we are going to put the members of this one here with the members of this one together, but without any repetition. So now let's look at it together. If, for example, here we have this one here, 1 is here, 1 is here, so we just pick 1. 2 is here, 2 is here, we will pick 2. 3 is here, 3 is here, we will pick 3, right? 4 is here, here we have 4. Here we have what? 5 is not here, here we have 5. Here we have 6, here we have 7, right? So now after this one here, then we also have A, C, F, G, right? So I want to pick what? A, C. Now remember, C repeat twice, right? So we are only going to take what? 1 C. Then here we have what? F. Here we have what? G. So that means the union of these two sets here we are combining all the elements here and here together without any repetition, without any what repetition. So this is what's called union of what of sets. Union of sets, that when you are uniting two different sets together, right? It's called union of sets. So we are done with this union of sets. We are, in our next video, we are going to solve much problem, but here we are talking about set what mutation. So this is called union of sets, right? So the next one I want to look at is what number four, which is called intersection. Intersection. It's called what? Intersection of sets, right? And it's denoted like this. It's called intersection of sets, right? Now the word intersection, what does it mean here? Now you are going to find what the common element between two or more sets. So the common element between two or more sets. So that's called intersection. The common elements between two or more elements. Right there, or more elements. So sorry, the common element between two or more sets. So the common element between two or more sets. It's okay. So we talk about intersection here. That is the common element between two or more sets. That's called intersection. For example, here we have. We have A. Let us use A. Here we have A, B, C, D, and E. Right? Here we have this one here. I will always use simple one. Then here we have B. Here we have what? Now here we have two different elements. Here we have A, set A, and what set B, right? So here we have the various elements. Here we have what various elements. Now they should ask you here, what is the intersection of sets of these two sets? What is intersection of these two sets? So here we're going to be A intersect to intersection to B, right? Now, what do I mean by intersection? The common element between two or more sets. So if you look at it very, as I said, what are the common elements or member between these two sets here? Here we have A, B, C, D, E. Here we have G, A. So A is among. So you have, because A is here, A, right? U is here, but U is not here. Fine. X is here, but X is not here. E is here, and E is here. So here we have E. You see that? So F is here, but F is not here. So when we talk about intersection here, element that are present in both is that is common between set A and set B, or between two or more sets. That is called intersection. What is common between here and here? So when you combine it together, intersection, you have this one here. Just that's called intersection of sets. As easy as that. So let's look at what the next one here. Complements of sets. Now, what do you say by complement of sets? Just now, when we talk about complement of sets, you actually are comparing that given set to a universal set. Just now, so when we talk about complement of sets, there must be a universal set and a set. So you are comparing that set to the universal set, right? So when we talk about complement of sets, elements in the universal sets that are not in that given set are called complement of sets. I'll go again. Elements in the universal sets but are not in the given set are called complement of sets. For example, here we have, let's say we have a universal set here, right? Universal set is having 1, 2, 3, 4, A, G, F, E, and I, right? It's okay. Here we have this one here. Here we have some here. Then we now have K, right? Now let's say K is a subset, right? Now remember I told you that in the first video I told you that a universal set is a model set, right? That gives birth to other sets, right? So a universal set is a combination of other sets. Why subsets are set derived from the universal set? So let's say this K here is a subset to this one here. Is a subset, sorry. the subset to the universal set, and it's having what 3 G, E, and 2, right? So if they ask here, what is the complement of set? Now the symbol is going to be KC, that's called complement of a set. So you now ask yourself, this is the set. We want to look for the complement of this set here, right? What are the elements in the universal set that are not in this given set? It's going to be the complement. So in the sense that the element that are the elements or members in the universal set that is not here are called complements. So if you look at this very well, 1 is in universal set, but 1 is not here, so put 1 there. This is that 2 is in the universal set, but 2 is not here, you put 2. Right? 3 is here, 3 is here, good. 3 is not. So 4 is here, 4 is inside the universal set, but it's not here, so put 4. Just that. Now, here we have A. A is in universal set, but it's not in the given set. So here we have what? A. G is here and G is here. G is not more, right? Then F, here we have F. E is here, E is here. Next one is what? Is I. Now, but here we have 2. Since 2 is here, so we remove this one here. So we remove this one here. So here we have I. Right? So you can see that this is the complement of this set here, because the complement means that all the members or any elements in the universal set that are not here are called complement of this set. So this is called complement of a set. As easy as that, right? So we are done with number 5. Let's move to the next one. Number 6 is called finite sets. Finite sets. Now we talk about finite sets. So number 6 is going to be finite sets. What is finite sets? Finite set is very easy. You know, like countable sets. Sets you can easily count. So sets you can count. They are called countable sets. Just so sets you can count. They are called countable sets. For example, here we have Z equals what? All students of pure PIC. It's okay. All students of PIC here, right? It's called countable sets. It's called what? Countable sets. All students of PIC is called countable what? Sets. Now, let us say here we have A. All the governors in what? Nigeria. It's okay. Now, as long as you can count those, as long as you can count those elements, they are called what? Finite sets. So they are elements you can easily count, right? As long as you can count those elements, they are called what? Finite what? Sets. Then we also have called infinite sets. 7 we call infinite sets. Now we talk about infinite sets here. These are sets you cannot count. Just these are sets you cannot not count. So they are uncountable sets. They are uncountable sets. D all counting numbers. Or you can say counting what numbers, right? So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there's no way you complete it. You continue to count to infinity, right? So all counting what numbers, right? Or you can say all natural numbers, right? Counting numbers and natural numbers, they are the same. Natural. Or you can say the natural what numbers. Right there, natural what numbers. Just so if a set is what infinite, mean that it can be what a counting number or a natural what number. This is what you want to put in your mind, right? Another one you find here is called set of integer from the negative to what, to the positive, called integer. Set of what, integer. Under what we can see here, let's say B set of what, integer. Set of what, integer, from -2, -1, 0, 1, 2, 3, 4, 5, 6. So they are called infinite what, set. They are called infinite what, set. So we have what called finite set. We also have what called infinite what, set. So these are things you need to put in your mind when you are talking about set what notation. It's called disjoint. Here we have a disjoint what, set. Now, what do you say by disjoint set? Disjoint set, when you have two or more sets that do not have a common element. Two or more sets without common elements. So when you compare two sets and there's no common element, that set is called disjoint set. For example, here we have A, we always use what, A, 1, 2, 3, 4, 5. It's okay. Then here we have B, A, B, C, D, and what, and E. Now, I want to understand here, these two sets are setable to be disjoint, because if you, the elements here are not the elements here, they are called disjoint. If you put the union of this set here, A union what, B, you have to get an empty set. It's okay, this one means what, an empty set, or it's okay, this one means what, an empty what, set. So in the sense that when two sets or more sets do not have a common element, they are called what, disjoint what, sets. Just as so they don't have common what element, that is meaning of what, disjoint what, sets. So let's look at what non-disjoint sets. So let's look at what non-disjoint sets. Now when we talk about non-disjoint sets, that is two or more sets that have at least one element in common. Two or more sets that have at least one element in common. So they have at least one element in common. It's called, they are called what, non-disjoint set. So when you compare two elements, when you compare two almost, or when you, let's say two sets, right? If they should have at least one element in common, they are called non-disjoint sets. For example, here we have X, which is that you have something like this: A, C, D, G. Here we have Y equals to, here we have U, F, I, A. Right? Now, if you check the union of this set here, you can see that A and X and Y, they have one element in common, right? They have A and A in common, right? So that because they have A and A in common, they have at least one element in common. They are called non-disjoint sets. So these sets are not disjoint. So if you should look at the union here, X union what, Y equals to what, A. It's okay. Unlike this one here, that is called disjoint set. When the two sets do not have any elements in common, they are called what, they are called what, disjoint sets. So this is the last you are looking at you in this class here. So do well to copy out every single thing you have learned in this video here. Put it inside your notes. It's very important to put it inside your notes, right? So in our next video, we will solve more problems related to what you have done, right? The first video we look at what set and various type of sets. In this video here now, we have looked at what the various set notation, because before you can start solving question under set, these are things you need to master and understand first before you can start solving question under what set. All this video is helpful. Please like, subscribe, so that whenever I upload another set of videos, you'll be notified. Thanks. See you in my next video.